Okay, welcome to Chapter 5. This whole chapter is going to talk about and introduce to you a concept called radicals, okay, radical expressions and equations. The first two sections will talk about radical expressions, basically how to multiply, divide, add, and subtract radical expressions, also how to simplify them and rearrange them to suit your needs. And the third section will talk about how to solve equations with them. So, first of all, what is a radical? A radical is any expression that includes the radical symbol, which is this guy. Okay, you probably are most familiar when you're square rooting something. Okay, for instance, square root 2. Square root 2, or I should say this symbol, in this particular instance, the index is not written. The index would go right here. And the index in this case is actually 2. Okay, 2 is the base, or the minimum amount, the lowest number possible for the indice. The index will be this value right here. So a square root, then it'll go a cube root, a fourth root, fifth root, sixth root. Even indices will be important when we're talking about something called restrictions on the variable, where odd indices will have no restrictions. So, the index we're going to get to a bit later. The radical symbol, as you can see, is what you'd probably say a square root sign. And the radicand, which is a term I'm going to use quite often, is basically the guts, the insides, or the expression underneath the radical symbol. So, you can write numbers, okay, in this form right here. This is called a mixed radical form. Okay, maybe I'll put that in brackets. That's mixed. Or you can write that expression like this. Square root 8 and 2 root 2 are actually the same value. If you plug them in your calculator, you're going to get the exact same decimal expansion. The question is, how do you go from one area to the other? Going from root 8 to 2 root 2, that would be a simplification, typically. That's called simplifying. Going the opposite direction, not as common, would be going into radical form, okay, or entire radical form. So, before we get on to that, let's just take a second and talk about restrictions. A restriction is basically saying values that the variable underneath the radicand cannot be. We're only going to care about this when the index is even, like 2, 4, 6, and so on. If that's the case, then the whole value underneath the radical sign, right here, this whole value, in this case, 4 minus x, has to be greater than 0. So when you take a look at this expression, basically to determine the exact restrictions on x, I'll write basically an inequality with respect to 0. So 4 minus x has to be greater than or equal to 0, which means 4 has to be greater than or equal to x. That means this expression right here is only defined when x is less than or equal to 4. Otherwise, this guy would be negative, right? So you don't want this, or you don't want something like this. Okay, you can't compute these. These are undefined. Just to note that square root of 0, or basically any indice of 0 is equal to 0. Okay? So, let's do some examples. We're going to convert mixed radicals to entire radicals. These examples I've outlined for you. Okay, here are the solutions. If the solutions are a bit hazy to you, doesn't make sense too much, I'm going to do absolutely similar examples. Okay, these would be your practice problems. So I'm going to work through them. Here it is, video 5.1. We're looking at it right now. So let's start with A. Basically, I want to write 4 root 3 as an entire radical. I want everything to be underneath this square root sign. To do this, you want to work backwards, or you want to basically express this integer as a square root. So basically it's very simple. What if I just square 4, then take the square root? Square root of 4 squared is just 4, so I haven't actually changed this expression. So that's completely legal, but this allows me to write everything underneath one symbol. Okay, these two are equal. 4 squared is simply 16, so this is 16 times 3. 16 times 3 is simply 48. So this is square root 48. Square root 48 is equal to 4 root 3. These are the same expression. Okay. Next one. I'm going to try to write neatly here. J cubed times square root j. Same thing. This is the exact same type of question. I'm going to try to write everything under a square root. So basically in this case I'm going to square this and then square root it. Makes it look ugly, but that's okay. I'm going to simplify this right away. Okay. Basically what I have here is I can, when you square an exponent, you multiply. So that will leave me with j to the 6 and times j, which is just square root j to the 7. My j's look very messed up, but no worries, that is a j. And this is a 7. Okay. So far so good, hopefully. And then taking a look at b, we have 2k squared times cube root 4k. So this time I'm going to cube everything and then take the cube root, okay, which will give me back the same expression, all times cube root 4k, which in this case I get to write everything underneath this cube root. I'm going to simplify it right away. 2 cubed, so I'm looking at this guy right here. 2 cubed is 8, and then we have k to the 6th times, and this is all times 4k. 4k. Okay. 4 times 8 is 32, and k to the 7. There you go. So it's pretty basic. Okay, you just have to go slow, make no mistakes, and you'll be fine with this. We're going to do the complete opposite, obviously. Okay, this procedure of going from a mixed radical to an entire radical is useful in some circumstances. We're going to find that this next procedure is more useful for us when it comes to solving equations later on. Basically, you're going to start in an entire radical, and you're going to take out everything you can to simplify it. Basically, you're going to look at the radicand. Okay, sorry, you're going to look at the index, and that will tell you what type of things you can take out. So for instance, you're going to look for squares here. Okay, what squares appear, perfect squares appear within 18? Well, 9, when you square root 9, you get 3. So you're going to try to pull out square root 9. Okay, note that root 9 times root 2 is root 18. Okay, that's how multiplication will behave in radicals. So again, here's your examples. I outlined the solutions, so make sure you look at these and read them and make sure they make sense. If they don't, this is the video to help you here. Practice 2. Let's try it here. Let's simplify these guys. Okay, and we state any restrictions. And I actually believe, so I apologize here, I believe in the previous question I was supposed to state some values for which the radicand is a real number. Again, I was supposed to state restrictions. Okay, let me just do that in a different color here. Sorry about that. So restrictions, and this is for b. In this case, the only value underneath the radicand, or sorry, against the again below the radical sign, is j. So j has to be greater than or equal to 0. For c, 4k. Oh, I apologize. For c, this is an odd index, so there are no restrictions. And that's it. Now let's return to our practice 2. Here we go. Part A. Okay. Square root 52. Let's simplify this guy. Very simple. This will take a bit of practice to see. Basically, you're going to try, this is an even number, so try 4. Can you take out any 4 from this? By going 52 divided by 4. And take a look, it's 4 times 13. 4 times 13. I tried 4 not 2. I tried 4 because 4 is a perfect square. Okay, so this is the same thing as saying square root 4 times square root 13, which is the same thing as saying 2 root 13. Okay, well, my writing's improving here. This is good. Halfway through the course, we're getting better writing. Just a bit better. Okay, the next one is 4th root of m to the 7. So basically the index here, the index will tell me what type of value I want to generate, or I want to kind of take out here. And I want to take out m to the 4 because the 4th root of m to the 4 would just be m. So in this case, I'm going to rewrite the inside as m to the 4 times n to the 3. Remember, multiplication of variables like this, you add the exponents. So this is equal to the 4th root of m to the 4 times the 4th root of m to the 3, which won't simplify, but this will simplify to be m 4th root of m to the 3. So it's kind of interesting. You're actually almost making it look uglier. Okay, simplifying isn't very intuitive in this case. This last question, 63n to the 7, p to the 4. Again, let's try things for 63. 63 clearly is odd, so you're going to be trying your first odd perfect square, which is 9. Let's try 9. Of course, it goes into it. 9 times 7 is 63, so let's rewrite this as 9 times 7 n to the 7. My 7s are always so weird in this program. Maybe because I'm writing like a super small here. We'll write a bit bigger here. Right away you can pull out this 9. You're left with 7. And you could rewrite n to the 7, can't you? You could write it as, as n to the 4 times n to the 3. And I'm going to do that because n to the 4 square rooted will simply be n squared. Okay, so it's a bit of a puzzle. P to the 4 is great. We're going to pull it out. Square root of 9 is 3. I can pull out n squared. I can pull out p squared. That leaves us with 7 n to the 3. Okay, and that's that. Now let's state some restrictions. I guess I always do that at the end. Okay, restrictions. Oh yeah, look at that writing. Restrictions. There we go. Maybe I'll keep it in red. Restrictions for A, well, there's no restrictions because there's no variables. For B, even index. Therefore, we really want m to the 7 to be greater than or equal to 0. So take the 7th root of both sides, and m has to be greater than or equal to 0. Okay, that one's pretty easy. Next one's similar, except, next one has 2 different variables. Okay. Now, a couple things. First of all, you know that, 3, there we go. 63 n to the 7, p to the 4 has to be greater than or equal to 0. So just get rid of the constant value. You're left with n to the 7, p to the 4 has to be greater than or equal to 0. Here, in this case, the exponents are odd and even, so don't try to get clever here with if you put a -1 for both, for instance, that's going to be negative, so that's not going to work. Basically, at this point, you can divide by p to the 4, for instance, and you're going to get n has to be greater than or equal to 0. Similarly, on the other side, p has to be greater than or equal to 0 if you're divided by n to the 7. Okay, so those would be your restrictions. Everything has to be positive in this case. Okay? And of course, to finish off this section, we're going to talk about adding and subtracting radicals. This is like adding apples and apples and oranges to oranges. Or, I think I put a little hint. This is just like adding 5x and 3x, okay? Which makes 8x. Basically, they have to have the same index, and you're good, okay? Same index and same radicand, actually, that's very important. Okay, so the insides have to be the same. So in this case, you can't directly add this. You're going to have to rewrite it. So let me actually take a look at something I've already worked out for you. Okay. You have to have it so that your index is the same and the radicand is the same. So 5 root 2 plus 3 root 2, of course, is 8 root 2. Okay, that's where this little hint comes involved. So name of the game is to, if you need to, rewrite the radicand so that they're the same. Okay, for a, they're already the same. 2 root 7 plus 13 root 7. Okay, this is literally no steps. This is just flat out 15 root 7. Okay, 24 minus root 6. Well, this one, I need to rewrite 24 such that I get a root 6 out of this. Okay, don't bother with this root 6 because that's a lower number. Here you can clearly write this as 6 times 4. Okay, minus root 6, which would equal 2 root 6. Okay, because square root 4 is 2 minus root 6. Hopefully you see that. Okay, I kind of omitted a step. I'm starting to just omit a step where this is actually equal to root 6 times root 4, right? That's the next step, really. And then that follows here, and that goes here. You get 2 root 6 minus 4. Okay, I throw the non-radical out front. Okay, this comes out to be root 6. There's really a 1 in front of here, so it's 2 minus 1 basically. And the root 6 is identifying what you're working with. This last one, negative root 20x minus 3 times root 45x. You can rewrite 20 as 4 times 5. And yay, there we get our 5x. You can kind of see it because you can rewrite 45 as 9 times 5. Look at that. So here you're going to have, and again I'm going to kind of omit this little step here. Square root of 4 is 2, so you're going to have 2 root 5x minus 3 times 3, because square root 9 is 3, times root 5x. So it's really 2 minus 9, which is negative 7 square root 5x. Okay, so this last question is a bit tricky. Okay, this 3 came from there. 3 times 3 is 9. 2 minus 9 is negative 7. So, like everything else in math, practice will do you well here. You need to practice at different situations. I've gone over the basics, basically. But you can get questions that will just be longer, more terms, that will take longer, more simplification, make you think about the different numbers underneath the radical signs. Sometimes it's not going to be so easy to see 45 and 9 times 5. It might be, say, 195, where it might be a bit trickier. So, do the practice problems. When you're ready, move on to section 5.2.